Next question number 3, which involves group 14 elements. So the question is, group 14 of the periodic table contains elements carbon, silicon, germanium, tin, and lead. These elements form compounds in two oxidation states. For example, carbon forms two oxides, carbon monoxide and carbon dioxide. Lead forms two oxides, lead oxide and lead dioxide. First question, so identify the oxidation state of carbon in carbon monoxide and in carbon dioxide. So to identify oxidation state of carbon, you need to remember zero-sum method that shows that all molecules oxidation state is zero. So here we have oxygen, which has most stable oxidation state is -2, here -2. So as their molecule, the total oxidation state must be 0. So in the first case, when we have carbon monoxide, is X plus -2 equals to 0. So we get X plus 2 in the case of carbon monoxide. And in the case of carbon dioxide, X plus -2 multiplied by 2. Why 2? Because here we have 2 atoms of oxygen. So equals to 0. Here you get X equals to plus 4 for carbon dioxide, for the carbon in carbon dioxide. Okay, next, so 1 point. So if you don't write one of them, so you will not score the mark. So please be careful. Which oxidation state of carbon is more stable? For carbon is more stable is +4 oxidation state when all electrons in outermost shell, so 4 electrons, are involved in forming bond. Okay, next question, write a balanced chemical equation for the reaction involving carbon monoxide and carbon dioxide in which the more stable oxidation state of carbon is formed from the less stable oxidation state. So more stable is carbon dioxide, so it will be in the product side. Okay, and from less stable is carbon monoxide. Yeah, carbon monoxide. So what we need to add oxygen. So when we add oxygen, we get carbon dioxide. So we need to balance this reaction. So balance it. So when you write chemical reaction, please don't forget about to balance. So you can put here 1 divided by 2. So we get carbon dioxide. Also, you can write physical states. So all are gases. Here, gas, and also here is gas. Next question. Lead dioxide is oxidizing agent. Write a balanced chemical equation for the reaction that takes place when solid lead dioxide is added to hydrochloric acid. So here is lead dioxide is oxidizing agent, so it will be reduced. Okay, so lead O2 plus HCl equals to. So most of the students confuse when they write chemical equation here. So here you have a hint, just says oxidizing agent, so it's reduced. That means oxidation state of this lead here, which is +4, is reduced. So to what oxidation state it will be reduced to? +2 oxidation state. So when it reacts with hydrochloric acid, we form lead Cl2, and so as lead is oxidized, I will say that HCl will be, so here we have chloride is reducing agent, so it will be oxidized. So from -1 to 0, Cl2 0, and plus, as we have hydrogen oxygen, it will form water, H2O. So you need to balance. So again, balanced chemical equation. So here we put 4, and here we put 2. So that's all. Next question. XCl4 compounds of group 14 elements are liquid at room temperature. Thermal stability of these compounds decrease down the group. Draw the structure of lead tetrachloride. Explain why the liquid at room temperature. Write down thermal decomposition of that tetrachloride. So first question. So first it says draw the structure of lead tetrachloride. So lead tetrahydrochloride has tetrahedral structure. So here we have chlorine, here we have chlorine and shadowed line, so yeah, chlorine and with dashed line. So this is structure of lead tetrachloride, so it has tetrahedral structure. Explain why they are liquids at room temperature. So the first point is they have simple molecular structure. Okay, molecular structure. Molecular structure. Okay, second point. And liquids, because they have simple molecular structure, and because of that they have weak van der Waals forces. So third mark. Okay, van der Waals forces. So last one is to write thermal decomposition reaction. So here we have lead tetrachloride, which is liquid again, so physical state, don't forget. So here you have hint, liquid state. When it decomposes, so heating, you get lead CO2, which is solid, and Cl2 chlorine gas. So here for this 1 mark, and for the van der Waals mentioned 1 mark, and for the reaction is 1 mark. So we get 4 mark, full 4 mark. Next question. How do the stabilities of the +2 and the +4 oxidation state of the elements in group 14 vary going down the group? Use examples taken from at least 2 of parts A, B, and C of this question. So here, +2 down the group. So stability of +2, stability of +2 oxidation state increases down the group. Okay. Increases down the group, while stability of +4 decreases, so down the group decreases. Okay, why? So we can explain because of we say due to inert pair effect. So here you can also explain what's inert pair effect. Poor shielding of D and F orbitals, only in the case of poor shielding of D and F orbitals. So orbitals, so only 2 electrons from outermost shell is used to form a bond. So while because of this poor shielding of D and F, while N s2, so 2 electrons in s orbital, while ns2 remains, so it will not form bond. So that's why plus 2 increased the valence group, while plus 4 is decreased. Okay, so this was question number